Hello friend, today we are here on the topic spring. Spring are the elastic material which are used to be observe the shock and the force when we are going to apply on it, it's going with some deformations, and when the force is unloaded, it's going to be regain its original position. So today we are going to be study some terms related to the spring. Before that we have the different two types of spring, open coil spring and closed coil spring. Today we are going for the closed coil spring. If we are going for the diagram, in this diagram we have given 2D. Small d is the wire diameter, capital D is the mean coil diameter. What is the P is acting at the center of the spring. Now if someone asks about this should be your R. This is a mean coil radius. Now what we have to do here, first of all we have to know about the strain energy. The strain energy is the energy which is stored within the body. We can say like a spring. So strain energy due to the torsion, because the spring are subjected with the both torsion and bending both. So torsion is always equal to the 0 to L. This is the total length L, 0 to L, Tx square. Tx is your torque, dx is that is small distance, to Gj. Gj stand for the, is your modulus of we say the rigidity, and J is your polar moment of inertia. Now if you go with that principal stress and strain formulas, where we have gone for the perpendicular axis theorem and parallel axis theorem. In the, my dear friend, perpendicular axis theorem, we know that the Izz should be equal to the Ixx plus Iyy, and as we know that the I for moment of inertia for the circular section is always pi by 64 d ki power 4. So if you go for the Izz should be equal to Ixx plus Iyy, means pi by 64 d ki power 4 plus pi by 64 d ki power 4, means the summation of both will be give the resultant effect that should be your pi by 32 d ki power 4, and that's the reason I am using the J should be your pi by 32 d ki power 4. Now if someone asks about the torque, we are applying the force P and this your mean radius R. So what is the torque? Torque should be your product of P into R. This is also indicated by the equation number 1. Now dear, in this equation where the strain energy, we are using the strain energy. On making its integration, the value is your T square L upon 2Gj. Now the question is, what is the L? Whatever the circumferential distance they are going to be covered, multiply with the number of turns or number of coils. So that is the formula, N into 2 pi R. That should be your length of the L. We have right now torque, we have right now J, we have right now L. Putting all the three value in this given equation, my dear friend, putting all the value in the equation, we have U is equal to P into R, that is a T square L and 2 pi R by 2Gj. The final outcome will be, on solving we will have 32 N R cube P square upon GD4. I repeat it again, this R is yours mean coil radius and the small d is the diameter of the wire. So this is your strain energy. Whenever the question will be asked about the strain energy, and if the derivation will be asked for the strain energy, you will easily make it. Now what is the axial deflection? We know that whenever the load is applied, it's going to be some axial deflection. So what is that axial deflection? So here we have the formula, F is equal to minus kx. We know that that x is known as axial deflection, and minus sign is shown that the effect is always coming in the opposite direction. So I am not consider the negative effect here. The axial deflection is somewhere the differentiation of the strain energy with respect to the effort or the force applied. So we have already strain energy in the previous equation, that is your 32 N R cube P square upon GD4. Putting the value here, because it's going to be differentiated from the P square is going to with the 2P, and that 2P will give you the resultant of the axial deflection 64 N R cube P upon GD4. That is your axial deflection. But there is a property that is known as stiffness. How the material is stiff, and on behalf of that we are going to be applied the load. So for the stiffness, which is a K, we have the K P is equal to stiffness multiplied with the axial deflection. Now if we want to this K, P upon axial deflection, P already that is a force, axial deflection we have come across with here 64 and R cube P upon GD4. On putting the value PP is going to be cancel out, and we have the equation and we have the formula GD ki power 4 upon 64 and R cube. Now sometime they are asking which sort of stresses they are going for. They are going for the tensile, they are going for the compressive, but my dear friend, for the wire it's always subject with the shear stress. So for the shear stress, as from the torsion equation, T is your pi by 16 d cube into tau. Now what is the T? In the previous equation we have known about the T is your P into R. Putting the value P into R, then what is the tau? P into R 16 divided by pi d cube. Somewhere we have got here, that is the shear stress 16 PR pi d cube. And these are the 4 terminology which we are basically used in the spring, and they will generally ask in the examination. Thank you very much. Stay tuned for the next video. Thank you.